I am going to continue with the Unit 6 Linear Models review chart. I think my last video got cut off at the end, so I'm just going to start down here and say again what I think might have gotten cut off. This last scatter plot right here, if there's no direction for the points, so these points we would say are going up, these points we were saying were going down. If there's no real direction on points, that's when we say that there's no correlation. And if you look at this graph, it is looking at shoe size and colors in a rainbow, and we know that those two things are not related to each other, so it makes sense that the graph wouldn't have correlation. Moving on to the back, the next topic we did in Unit 6 was line of best fit. And basically what we're doing here is we are going to look at a scatter plot and come up with a line that basically follows the path of the points on the scatter plot. And then once we pick that line, we will go through and find the equation for it. So what we are doing is the line of best fit. This is a line that we draw that is going to follow, so that follows the path, or we could say the trend of the scatter plot. So it wouldn't make sense, scatter plot, sorry. It wouldn't make sense on this graph to do a line going in this direction because the points on the scatter plot have a positive correlation to each other. So when we draw a line in this scatter plot, we were going to want the line to go in this direction. Now, what we're going to do is we need to decide where that line looks the best. I have this sheet of paper right here just to kind of help out to make a line, but I can kind of see through the points. It wouldn't make sense for us to put the line down here because that's really below most of the points on the scatter plot, just like if we drew the line up here, that would be above most of the points on the scatter plot. So what we want to do is basically draw a line that follows the trend of the scatter plot. We don't want it to be too steep. We don't want it to be too shallow. We want it to follow the trend of the scatter plot. So in order to do that, we're going to pick 2 points. So pick 2 points to make the line. Now, you do not have to pick scatter plot points, but since this doesn't really have a graph behind it so much that I can see, I think there is one, it's just not very dark. I'm going to go ahead and pick 2 scatter plot points. So when I place this on here, I think I might pick these 2 points right here. So I'm going to pick that point and that point. So you're going to pick 2 points on the scatter plot to make your line. So then I'm going to use this sheet of paper as a straight edge here. So I'm going to connect those points. I don't know if I did that bit of a job. Well, that's all right. And then remember that this is a line, so it does continue on. So as you can see, this line is following the points on the scatter plot. So now what we need to do is to come up with the equation of that line. So what I'm going to do is we want to write the equation y equals mx plus b. In order to write this equation, we need to figure out what the m is and what the b is of this line. So first thing I'm going to do is use those 2 points and find the slope. So find the slope. Now, I can do that 2 ways. I can either find the slope by subtracting, or I can just count a rise over run. So I think what I'm going to do, I'm going to try and count. So I think this one looks like it's right about 60. This one looks like it might be right about 80. So it seems if I do rise over run here, I'm going to go up 20, and then it looks like this one is around 3 and this one might be around 6. So I'm going up 20, and then I'm going over from 3 to 6. I'm going over 3. So I'm going to say that the slope of my line is rise of 20 and a run of 3. Now, if I could reduce it, I would, but I can't. So I'm leaving it like that. All right, the next thing that we're going to do is estimate our y-intercept. So, estimate the y-intercept. Now, what that means is that we want to look at where our line crosses the y-axis, because that's what the y-intercept is. So I'm going to adjust this, and perfectly works. So give me just a second to focus here. Okay, so I am looking at where does this line hit the y-axis, and it looks like that landed almost exactly on the 40. So the B is 40. So what I did is I took the 2 points, I drew the line, I counted the rise and the run of those 2 points to get my M, and then I looked on the graph to see where did it cross the y-axis, and that's what the y-intercept is. So now the equation of the line that I drew is y equals 20 over 3x plus 40. So let's just take a look at what this graph is actually even telling us. These are the hours spent studying and the score on the exam. So what this is saying is that the more you study, the better you'll do. And we know that that's true. So this equation is saying if I don't study at all, I'm probably going to make a 40. But the more I study, the better my grade will be. And in fact, my grade is going to, if you think about 20 over 3 is almost 7. So every hour that I study, my grade is going to be 7 points higher. So I start off, if I don't study at all, this is saying my initial amount is going to be a 40. But if I study, every hour that I study, my grade is going to go up 7 or so points every hour. All right, let's move on to frequency table. This was the last part of Unit 6, and a frequency table is once again just another way to show information, kind of like a scatter plot, but it looks completely different because it's not really a graph, it's a chart. So I'm going to say that a frequency table is a chart that shows the frequency of related data. All right. Now, if we look over here at our chart, Tommy surveyed students at his school and found that 78 own a cell phone, 57 of those also owned an iPod, 13 students do not have a cell phone but have an iPod, 9 students don't have either. So now we have to kind of summarize this information here. So let's just start right here. If I look at this column of this two-way frequency table, this is showing me the number of students that have an iPod. So if I add these together, I should come up with 70 students that have an iPod. All right. If I look going this direction, this is telling me how many students have a cell phone. And I can see that 78 students have a cell phone. Well, 57 of those students have an iPod. So now I need to think about it. It's a pretty simple operation. All we need to do is subtract. How many students have a cell phone but not an iPad? And if you think about it, that's going to be 21. All right, so now let's look at how many students do not have an iPod. If I look at this column right here, this is how many kids do not have an iPod. So the total number of kids that do not have an iPod would be 30. All right, let's go across to this one. This row right here is showing me how many students do not have a cell phone. So if I add that together, I'm going to get 22 students that do not have a cell phone. So now I'm looking at this box right here, and this box is very special because this box tells us how many, the grand total, how many students, right here, here's our grand total, how many students were surveyed. So it says Tommy surveyed student at his school, but it doesn't tell us how many students he surveyed. So we have two ways to figure it out. We can either total up this way, or we can total up this way. But whichever way, we're going to get the same answer, and that is 100 students. So 100 students were surveyed, and now we can look at the chart and tell a lot of information. So what we want to do is anytime we talk about the information in this table, we always want to use the grand total. The grand total. All right, so if I asked maybe, how many students did not have a cell phone? So if I wanted to know how many students did not have a cell phone, then what I'm going to do is look at how many students. That's talking about the total number of students that didn't have a cell phone. 22 out of 100 students that were surveyed did not have a cell phone. All right. What if I asked you how many students had a cell phone and an iPod? All right. Now, if we look at this, I want to know how many students had a cell phone. But I'm not talking about 78. I'm only talking about how many of those students also had an iPod. That's going to be this number right here. And that would be 57 out of the 100 students. And at this point, we could make these into percents. And you should know that 22 out of 100 is going to be 22%. But you could always use a calculator to divide if you needed. And 57 out of 100 is 57%. So a frequency table is going to tell us how often something occurs. So it shows the frequency of the data. And in case you're not sure what frequency means, that is how often something occurs. So we were just talking about iPods and cell phones, but it could be anything. So that covers your Unit 6 review chart. So now you can complete the Unit 6 practice.